Right. So today we see what is current. So current is basically flow of electric charge. That's it. So we know that every material have electrons. So when we use some power source like battery, which have the energy in the form of potential energy, and some load like light bulb. So what happens? The electrons flow from the source to the load like this, and these electrons or these charges is the means of transferring the energy from this battery to this bulb. So now you understood what is electric current. Electric current is basically flow of electrons happens between source and destination and so on. So you can understand it with the analogy like water is fall from higher altitude to lower altitude. Similarly, electrons flow from high potential to low potential. So SI unit for the current is amperes. And there are two types of currents, that is direct current, that is known as DC current, and alternating current. So basically in our case and in our course we will just deal with the DC current more. We won't deal much with AC current. So I will not explain this part in depth. So basically in alternating current, the direction of electrons is changing periodically. So I hope you understood the current. Now quickly let's see conductors. So we saw what is current, the flow of electrons, flow of charges through the conductor. So what is conductor? Conductors are something which allows the electron flow through it easily. That's it. So any material which allows the charges to flow through it easily is known as conductor. And opposite to that, there are some materials which don't allow the current or charges to flow through it easily. Those materials are known as insulators. So now, because we understood the conductors and insulators, and we already know what is resistors, it is something that resists the electric current. So there are different type of resistors, that is carbon resistors, and we can have the wire resistors, metallic resistors, ceramic resistor, and so on, so forth. So resistors is nothing but the electrical component which we use to put the hindrance or resistance in the path of current. So why will we ever do that? So simple answer is to control the current. To control the current, we use this component. So in this video, I already explained about the resistor and their basic concepts, as well as how to find the resistance of carbon coated resistor. Now let's see the voltage. So voltage, we can think of it as a push or pressure behind the flow of current. So when I was giving you the example that current flow from higher voltage to lower voltage. So voltage is that push which is making current flow through the circuit. Okay, so we have the energy, potential energy in our batteries, and according to the amount of energy and the resistance of conductors, this this push is decided. So to find the relationship between the current and voltage, so we understood voltage is something that pushes the charges flow through this circuit. To understand the relationship between these two, we will see the Ohm's law. So as you can see, this is the voltage which is pushing the current, and this is the resistance of the material that is stopping the current. So if there is more resistance and we want to supply the current, then we need higher voltage, higher push. Correct. In case we don't have higher push, then we won't get the sufficient current or desired amount of current. So Ohm's law basically say I is equal to V by R. That is amount of current is directly proportional to the amount of voltage, and amount of current is inversely proportional to the amount of resistance. So that means if resistance increases, amount of current decreases, and if voltage increases, amount of current increases. So I hope you understood these concepts. That's it for today's video. See you in the next video. Till then, bye.